All right, welcome everybody. So this session is on Java on devices. We are going to have a plethora of demos, different applications where you can run Java on embedded devices, devices where you can access them via Java APIs. So we're going to have a whole lot of fun. And one unique thing about this session, I hope you guys are not camera shy, but we're actually live streaming the talk in the room here. So if you go to the Night Hacking website, nighthacking.com, you can actually watch us on the live stream. This is the tour page for the Night Hacking website. Here's the home site. If you guys tweet anything during the session to hashtag Night Hacking, it will go out over the Twitter stream and be live there. And we're actually live right now. And this is a little bit about the tour which I've been doing across Europe. So you can see where we are now in Paris. I've been on the road for 5 weeks so far via motorcycle, a few more to go. And this is the third conference and about the 25th event so far. You can track my real-time location on the map there. It also lists the upcoming events. So I finished I started in Germany where I rented the motorcycle, went through Czech Republic, Poland, stopped at Makerland Conference, Germany, where I spoke at JavaLand and also the Darmstadt Jug, Stuttgart Jug, a whole bunch of other jugs, Hanover Jug. Went down to Switzerland, France, Portugal, was in Barcelona last night. So lots and lots of fun, and you can find out more about the adventures here. The next few stops are going to be in India, where unfortunately no motorcycle. Okay, so that's a little bit about the Night Hacking Tour and the event we have here. Now let me introduce myself. I'm a Java Technology Ambassador for Oracle, also the Java 1 Content Share. And with me?
Christophe Vaille from Oracle and Java Architect, basé en France, faisant partie d'une équipe américaine. Et je vous parlerai en français.
Okay, and if you guys wouldn't mind, we did our introductions, but could we get maybe 2 or 3 people in the room to introduce themselves for the live stream? So I have the magical microphone which is connected to the stream. Anything you say over here will be heard, and we're going to play the mic passing game. So you don't have to speak. This is completely optional. If you do speak or you say anything at all on the stream or you ask a question or anything, you'll get a prize. We'll give you stickers, and you can pass the mic around till we get to somebody who actually wants to say hi. And whatever's on the screen is actually what's going out over the live stream. So I have to switch inputs. You might want to stand up and project to the room because these guys won't be able to hear you since that's not hooked up to the audio system in the room. No, just turn around and speak loud enough they can hear you. Oh. We're still on as I'm tripping over my cables. So apparently I should not quit my day job as an evangelist and be a cameraman. I would get fired. Okay, so, please. Yeah, okay. What sort of Java technology you use?
Java 7.
Java 7? Embedded? Or server-side development, client development?
Server-side.
Server-side, okay, good. Now pass the mic. Oh, and your prize. We have stickers. Now I'm gonna leave it up to my my co-presenter. Whenever anybody says anything, they get a sticker. Cool. Thank you. Sticker.
Sticker.
Server-side Java. Very nice. And let's get a couple folks in the other side of the room because we're not being fair.
Hi, my name is
Sticker.
Mohamed Ali Kubaisi. I work for Murex Paris. We work in Java server-side as well. Nice to meet you all, and thank you for this opportunity to see some non-server-side computation going on. And
Cool.
a nice robot, by the way, if you can get a hold of that. Pretty cool right there. There we go. All right, that's a note.
Hello, I am Mariel. I work also for Murex, and we work on Java server side. We build a financial platform.
All right, cool. All right, so thanks, guys, for introducing. Do you want to say something? No, you're good. You have to get to these guys. They want some attention. Okay. All right, so one of the conferences, excuse me, one of the conferences I visited was JavaLand. It was actually in a theme park, which was really cool. So what I was thinking for today's presentation is we would theme our presentation after a theme park. Everyone loves theme parks, right? Who loves theme parks? Make some noise if you're Yeah, so actually in the evenings we would go on the roller coasters and rides, and it was great fun to be guilted by your geek peers into doing things which make you throw up after having too much beer. So these are some of the topics we're going to cover. We actually have more than this. So we're going to talk about Lego Mindstorms. The new version actually runs Java quite nicely with the full JVM. Various development boards. I have my motorcycle side cases chocked full of development hardware. So I'll show you guys a bunch of that stuff. We have the Duke Pad, which is a homebrewed tablet. So that's basically just off-the-shelf consumer parts, which have been fabricated into a tablet you can hack. I'm going to show you Java running on iOS and Android. These are probably places where you don't traditionally think of running Java, especially UI frameworks, but it works quite nicely. And we're also going to show the Now robot, which is the little guy on the ground there. An appropriate place to put a very expensive robot so we can trip over him. And we also have a demo of Java embedded technology. Can you briefly describe what we're in store for?
C'est une démo sur le smart metering. Donc si vous connaissez un peu le projet EDF en France, Linky, donc c'est un peu même principe d'architecture et nous allons donc vous présenter Java SE Embedded, travaillant et relevant les données d'un compteur électrique pour les renvoyer sur un système IT. Donc un use case un peu plus réel dans le sens où il a été déployé en France et en train d'être déployé.
Okay, so I want to make sure that we don't disenfranchise any folks who are expecting an all English talk. Is there anybody who's only an English speaker in the audience who doesn't speak French? Okay, so 2 guys. me too, my hand's raised. So I think what we'll probably do for his section, because it'll go more fluidly in French, is we'll let him speak primarily in French, but then we'll mix in a little bit of English, so I understand, as well as our 2 audience members. Does that work for everyone? Okay. All right, so that's the plan for today. Now, first, a little bit about the Internet of Things. So this is some statistics about the number of devices versus the world population. And you guys have seen this evolution as people get cell phones and other devices which are hooked up to the internet. And now that embedded hardware is becoming fairly inexpensive and accessible for developers, you can do powerful things on it, there's going to be an explosion of devices that you're going to see on your person. So for example, anybody know what this is here? Let me. See, this camera is handy for stuff like this. Yeah, so this is the Nike, what do they call it? Fuel? Fitband? Nike Plus, I don't know. I'm bad at marketing stuff. But anyway, it essentially keeps track of your, through an accelerometer, keeps track of your movement and activity, and then publishes it to a web service. So they can, give you information about your fitness, compare you to other people of similar age groups. And there's a whole class of devices which are around health. So doing health services, health monitoring, heart pressure monitors. A lot of hospitals and institutions are looking at these sort of devices to, do blood pressure and have scenarios around keeping people healthy. In addition, there's, home automation. You probably saw recent acquisitions by Google in the home automation space and a whole bunch of different companies popping up which are all trying to do interconnected devices which will help you, like smoke detectors or thermostats or other things inside of your house. And this is continuing in smart cities and all sorts of other projects where they're embedding devices into your lives. Right now, most of these devices are connected to the internet. So you're kind of point to point where you're talking to a service or something in the internet. But increasingly, there's a trend towards having devices communicating in networks, sensor networks, or just talking to gateways, and then aggregating that information at a more local level. So this is the way which the network is changing. And a good example of this is this Centurion EHS5 chip, which this both runs Java ME, and it also has a 3G antenna built into it, or a 3G processor built into it, so it can hook up to networks. And it's a really, really tiny chip. So it measures 27.6 millimeters by 18.8 millimeters, and literally fits on your fingerprint. On the back of the chip is an LGA mount, so you can hook it up to a board with antennas and accelerometers and other devices. And one of the projects they used this for recently was to track rainforest deforestation. So they would embed the chips plus accelerometers and GPSs and a 3G antenna into the hulk of the tree. And then when folks would illegally deforest the trees, then they could track the trees to the location where they were being taken to. So just an example of using this technology for an environmental issue. And one of the things which I think it's important to understand the difference between, which in general, I'm just going to refer to the technology we're showing as Java embedded technology. But under the covers, it's either going to be Java SE embedded, which is a new product which came out with Java 7, or Java ME embedded. So ME comes from a long line of doing small footprint embedded development, and recently has been targeted at, focused on working on small processors, like the Centurion chip, anything the size of a Raspberry Pi, which we'll chat about, or smaller. And this is an example of, well, today in Java 7, so this is actually a couple weeks ago, what the difference is between the Java ME and the Java SE APIs. And you can see there's a fair amount of differences. The language level, it's a subset. So it was on Java 1.3 or Java 1.4 respectively, but the APIs were quite different as well. There were specific mobile APIs and JSRs for those which were different than the desktop APIs. In Java 8, we've moved towards converging these APIs. So Java ME8 is a much larger subset of the language. There's almost everything. I think it doesn't have lambdas in some of the features. And Java ME8 APIs and SE8 APIs are converging as well, where they're moving some of the APIs which were only available on embedded devices into the SE, and then moving the SE APIs back into ME. The long-term plan is to basically have small devices and large devices be on a common stack with different profiles you develop for. So there's less discrepancies between developing for Java ME versus Java SE. But in general, I'm just going to refer to stuff as Java embedded technology, and where appropriate, we'll clarify on exactly what we're using under the covers. And the last thing, do we have any folks who are not Java developers or who do a lot of embedded C development in the room? Okay, this is a Java conference, so that's expected, I would assume. But if you came from an embedded background, then there's a lot of benefits just moving from traditional native C code into Java brings. So for you guys, this is self-explanatory. Like you already know the benefits and you're using Java in your daily work. But I mean, if you think about it, for folks who have been developing on small embedded C, they have no garbage collection traditionally, so they have to do memory management themselves. Multi-threading is very platform specific, so they don't really have an easy way to do cross-platform threading. The implementations vary quite a bit between different processors and different manufacturers in terms of what they offer. Very difficult to update your code, port your code between different platforms. So there's just about a bunch of things which developing for Java brings you that the embedded development space just hasn't had for many years. Okay, and last thing on kind of the overview. If you want some more information about what we're doing with building out a community around Internet of Things, there's a new portal site, oracle.com/go/Java embedded, or oracle.com/IoT, and you can find out more information about what we're doing with Java embedded technology and Internet of Things, and then all the different social handles where we are tracking and broadcasting things which we're working on. All right, so you ready for demos? I think that's pretty much what everyone came here for. So basically, I think the way we'll do this is I have some slides to go into background and a lot of demos. And let's see, do you guys traditionally take breaks in the middle of sessions? This morning, do you guys just run through this morning pretty much? No break. Okay. So we have one other demo that has to come in. We have to get the guy to come in here and do it. And a whole bunch of demos here. So I think what we'll do is we'll kind of do speed demos and go through as much as we can. Then bring Alex in and talk a bit about what he's going to show, and Christoph's in the middle. We're going to chat about his stuff. And then at the end, with whatever time we have left, we'll let you guys come up and interact with the demos and play around with stuff. Because I think part of the fun of doing embedded technology is getting your hands dirty and playing around with it. And at any point, if you guys have questions, just shout it out or raise your hand. Shouting might work better to get my attention. And I'll also try to ask you guys questions along the way because we have a lot of stickers to give away. All right, so first guy we're going to talk about is our buddy here. So, does anyone know who this is? Raise your hand. Duke, I heard you. All right, sticker. And this is a very special Duke. He's got some stuff inside of him. Let me get an appropriate angle and zoom in on him. All right, so if you notice that Duke has mechanized internals. So does anyone know what version of I already mentioned it's Legos, but what version of Legos we're using inside of Duke? Okay, so you said Mindstorms. I want something more specific. Does anyone know exactly which? EV3. Very good. Okay, he gets a second sticker. Yeah, so this is using the Lego Mindstorms EV3. Now, on screen, I have the 3 different generations of Lego Mindstorms. I actually still have one of the old RCX 1.0 sets. So maybe I'm dating myself slightly by mentioning that. And those are cool, but they don't have enough processing power to actually run full Java virtual machine on them. Same thing with the NXT. The NXT actually uses the same sensors, so the sensors are compatible between the NXT and the EV3 set. But the EV3 is interesting because it's the first Lego Mindstorm set which has an ARM processor that's powerful enough to run Java. It uses a Citara AM1808 processor. This is a ARM9 processor running at 300 megahertz. Also on board it has an analog to digital converter, which is kind of cool. Normally if you wanted to do analog sensors, you would have to hook up an Atmel chip or an analog to digital converter or something to your Raspberry Pi or other development board. And then there's motor ports and sensor ports, Bluetooth built in, USB, and there's a micro SD card slot as well for expansion. So that's what I'm using to hack and put some Java on Lego Duke. So we have some motors. I'm using the large motors for his wheels. And inside of him, there's a small motor for his arms. So I don't normally do this, but who's curious? Who wants to see the internals of Duke? All right, I think that was most people. We're gonna do something very dangerous, and we're gonna crack Duke open in the middle of a presentation. Normally, I would highly disadvise breaking your toys before your presentation, but we're gonna do it anyway and have some fun. Doop. Oops. All right, one piece gone. That piece probably wasn't very important anyway. More pieces falling off. Okay, now we can get a good view of the inside of Lego Duke. So the internal frame is built up of Lego Mindstorms EV3 parts. Actually, my daughter helps me put it together. She's 10 years old, so the perfect age for playing with toys. Inside here, I don't know if you can see it, there's a gyroscope wedged in there. Oops, that wasn't a good sound. All right, so his arm came off too. And then these are the large motors down here. One of the things I found out, it took me about, 5 or 6 tries to actually get the balance working right on the Segway, because this is a Segway, so he stands up. But I figured out that the frame has to be fairly rigid in order to get precise feedback on the algorithm, because it needs to move the wheels to keep him upright. So that's why the wheels are directly connected to the large motors. Originally I was going to have him sitting on a Segway, but the axles to the edge of the Segway produced enough delay that he couldn't actually balance. And the other thing is the frame has to be fairly rigid. So the internal frame I built up quite a bit, and then I'm using these old Technic blocks. These are actually, I don't think most Technic sets come with these anymore, but they used to have these connectors where you could hook up the Technic sets to normal Lego sets. So I got some of those as well from my old Lego sets. Okay, so that's the internals of Lego Duke, who's now in shambles. Let's see. So we got large motors, we got the gyroscope, we have a pressure sensor in his hands, which fell off right here. We have a light sensor as well. The light sensor is pretty cool. You can use it for line following. It can also pick up certain colors. So I put it in this hand. I have yet to actually code anything and do anything with it. But it balances out the other side quite nicely. So it's aesthetic currently on Lego Duke. Maybe I'll program specific commands for that later. And then there's also an ultrasonic sensor. This one lets you detect distance pretty accurately. It only comes with the education set. And there's an infrared sensor as well. The infrared sensor comes with the retail set. So the major difference, if you were picking between the retail and the education set, the education set with the expansion set has more parts, so you can do more with it, and it comes with the gyroscope, which you need to build this particular model. The retail set, however, is relatively cheap in comparison, and it comes with both the infrared and also the remote control, which is on the other table. We are actually going to need this. But you can always pick up the spare parts and buy them directly from Lego. And then, of course, with the infrared, you can use the remote control to send some commands and then control those from your Java code. And then this is a little bit about getting started with Lejos. So Lejos is a library which has been around for a while, and it lets you talk to the sensors and program stuff from Java. So it's basically it's an education project, and it's pretty cool. But up to now, they had to cross-compile when they were developing for the previous Lego sets. So the nice thing about the EV3 is you can also use Lejos. They have a special version for the EV3 set, and it doesn't require cross-compiling. You can actually compile using Java 7 or Java 8 right on your computer, copy the jar files off, and we have a working Java embedded version that runs right on the Lego brick. So it's fairly nice. Setting it up is not too hard. You need a micro SD card of at least 2 gigabytes where you install Linux plus the Lejos libraries and Java embedded. A Wi-Fi adapter. I'm using the Edimax Wi-Fi adapter, which also works really great with the Raspberry Pi and has a nice small footprint. The other one up there is the official one, but it's much cheaper than the official one. So if you buy it from the Lego site, they charge you typical Lego pricing, which is way too much. But you can buy exactly the same thing, the Netgear WNA 1100, for like 1/3 the price on eBay, and it's exactly the same hardware you're going to get from Lego. But either one works just fine, and both are cheaper options than buying the official one. Nose. The nose is actually tricky because it fits in 2 ways, and only one of them's right. And that's not right. Huh. And we have a live reconstructed Lego Duke. His happy spot is being on his head and being pressed down. Okay. So we're gonna see if we can't get Lego Duke to do some cool stuff. This is a little bit more about how to actually compile the Lejos code. You don't only need Eclipse if you want to compile it from scratch, but otherwise you can use your favorite IDE. And then here's a really simple Lejos application to give you an idea of how easy it is to program using Lejos. So we're going to need a couple volunteers from the audience to do our Lego Duking. So first, who in the audience is a parent, a dad or a mom? Okay, let's get someone towards the back with the hat. Yeah, come on up. Now you're probably wondering, like, why would I single out parents in the audience, right? So this is going to be a demonstration of why. All right, so you need to see that? This is a dad grab of a baby. Right? He did two hands. When I was in, I'm picking a little bit on the guy who was in Geneva with me. But when I was out in Geneva, let me make this bigger. Okay. When I was out in Geneva, I handed it to the guy, and he held it, and he's like, oh. And you notice where the initially Duke wasn't glued at all, but now I put a few joints where I can open them up. And you notice one of the joints was right around here, and he just. Even with my gluing job, it couldn't hold together, and it was in shambles. But we did get him to balance without bricks, which was entertaining. Okay, so good, you're qualified. Now for the second volunteer, who's done like radio control car racing or airplanes or is good with joysticks? Okay, in the back, come on up. All right, so we're gonna first attempt to run the software on our Lego Duke. So I've already copied over the jar file. We have to SSH to Duke and then run the program. Now on the back of Duke, it should say 2 IP addresses. Just pick one and read it off to me. Okay, not that one.
1.3.
All right, thanks. Yeah, so this is a very secure password.
Pi, no.
Yeah, okay, so you read the slide. It's blank. Yeah, very secure. That's the default password they put on the Lighthouse distribution when you first build their image. You should probably change it if you're going to actually leave your Lego hooked up to any public network. Okay, and we've got stuff here. I got Lehos. I've got the files I've copied over. JRun is just a little wrapper which adds in the EV3 classes to the class path, and we will endeavor to run this. So probably for camera purposes, let's see. Okay, move out of the way now. Okay, now you can have this little spot. Let me see if we can balance him right here. And for folks sitting here, I'll have the camera focused on him so you can see on the big screen if it's not easy to see from your seated. But if you want to stand up and get closer, you're welcome to as well. Okay, so the way this works for balancing is you need to first get him perfectly still. So lying him on his back is a good position. So just put him on the ground, yeah, and lie him down on his back. Yeah, it's flat. Yeah, okay, good. Now, there's a little button in his right hand I mentioned, right? On his right arm, there's a button embedded in his hand. When you press that button, he's going to start beeping. And when he starts, he's going to beep, beep. You want to immediately pick him up and put him on his wheels and balance him as close as you can. When you get the last beep, let go. Okay, good job. All right, now the next thing for the control remote, on the table, right-hand side. Right. There. So the buttons, hold it that way, yeah? The remote sensor is in his butt. So shoot from behind. And the top 2 buttons are left and right. Yeah, so try one of those. Just click it once, and you should start spinning, hopefully. Yeah, okay. Now, all right, so that shows you what happens when you hold the button in, because it increments a counter. But if you click it once or twice, then it'll maintain speed. And then if you want to stop him, just press the big button.
Okay.
But just click it once or twice. Each time you click it, it'll go faster.
Okay.
And the bottom ones are backwards and forwards. So let's give you guys another try. So I'm going to restart the program. And then you get a second try to balance him. So lay him on his back again. Yeah, and then when you're ready, press the button and stand him up. All right, look up. Yeah, good job. And now we get to remote control him. All right. It's pretty good. So this is challenging because he doesn't have a lot of room to. If you want to stop him, the big button on top will clear his commands if he's rotating too much.
Where is the sensor?
In his butt. I was trying to hide the sensor so it wasn't too obvious. I could have put his sunglasses or something, but yeah.
Oh, yes.
Okay, now he's walking forward, slowly. Yeah. Backward. Nice. All right, so give these guys a big round of applause. All right, so we're gonna let Lego Duke hang out for a bit. Does somebody have a timer? A watch? So check you looked at your watch. You're the timer. Check the current time and let us know how long Lego Duke stands for, and we'll see if he can beat his previous record.
Oh.
He's a little angry right now. Okay, so these guys get, what do they get? Stickers, yes.
Merci. Bravo.
All right, so we've got first demo actually working. Lego Duke. And the second one we're going to talk a little bit about is the Raspberry Pi. I would highly recommend, how many folks in the room have Raspberry Pis already? Okay, good. So you guys are in the right place. Everyone else, shame on you. It's cheap. It's only 35 euros. And it's a great embedded platform to start. It happens to be our reference board for Java ME and Java SE, so you can run either on it. There's a great community around the Raspberry Pi, so it's really easy to get started. I'm going to show you some other development boards as well, but of all the boards, the Raspberry Pi is the brain-dead, easy, cheap way to get started with this stuff and has really good support. Some of the other development boards, you could easily blow a weekend or a couple weeks of evenings and weekends trying to get them working with the right Linux distribution and getting the right drivers installed and trying to get the right serial tip and everything working on your computer. So it's the Raspberry Pi is just really super simple, highly recommended. So processor-wise, what did anyone remember what our Lego Duke had as a processor? What? ARM9 and how many megahertz? Okay, so give him a sticker. So the Raspberry Pi has an ARM11
Sticker.
and runs at 700 megahertz. So this is like light years ahead of, well, it's still slow, but it's significantly faster. The Model B has 512 megabytes of memory. The Model A is 256. The Model B has Ethernet, and the Model A uses slightly less power, but they're both good boards. I'd recommend getting started with the Model B. You power it off micro USB. About an amp of power is sufficient to power the Raspberry Pi. A cell phone charger works really well for that. You can pop an SD card in as well for the hard drive. They recommend 4 gigabytes, but I'd recommend 8 just to get started. GPIO pins are really what sets this apart from a general purpose computer. Other than that, it has, the HDMI, and you can hook it up to a video screen. It has audio out. It has USB ports, so it looks a lot like a little tiny computer. But I think what really sets it apart is the GPIO pins, which allow you to control hardware devices, and I'll show you an example of this in a sec. Well, I guess it's time to show you an example. Here's the GPIO pins. This is the MPU 9150, which is an accelerometer, and it hooks up via. Oh, well, he didn't really fall. All right, what's our time on Duke? 3:30. Okay, so maybe he needs some hardware re-engineering to get him to last slightly longer. Okay, he says, "Oops, I fell."
There's no space for it to move, that's fine.
Was he hit bumping into the cords?
He bumped into the socket extension.
Oh.
That's why.
Yeah, the way the segue algorithm works, he attempts to maintain position. So he tries to know where his center is, and then as he's rocking back and forth, as he gets farther away from the center, it's designed so he'll go a little faster and he'll lean back and try to stay in place. And that's also how the forward and turning motions work. Is it moves his target center point, and then the algorithm compensates and he moves around a little bit. But it's probably not entirely accurate, so there's a slight drift. He eventually moves slightly forwards or backwards. Okay, so I think you did a good job. Mission successful, Mr. Duke. In a few more weeks, I'm going to take him back to California, and he'll get another visit to the glue spa to fix some of his broken bricks. All right, so raise your hand if you know what either of these ribbon cables on top of the Raspberry Pi is for. All right, so that was a good example of shouting out an answer without raising your hand. Anyone want to take a guess? Now remember, I said saying anything gets you a sticker. It doesn't have to be the right answer. Okay, in the back, what do you think?
I don't know how to say it in English, but acquisition? Capture?
Okay, capture of what? You're close.
Signal.
What?
Capturing signal.
Signal.
I mean, you can plug a sensor on it.
Okay, you're close, but not quite. Ah, okay, sticker. Oh, you can both get stickers. Yeah, so the Pi camera that the Raspberry Pi Foundation released last year is a good example of a sensor you can hook up to the Raspberry Pi. And I have that sitting inside the Duke Pad, which I'll show in a bit. The other port, anyone want to take a guess? Okay. Well, the other port is for an LCD screen. So you can hook up a touch screen display and LCD. A lot of embedded devices have built-in ports for supporting LCD screens. Now, unfortunately, the Raspberry Pi Foundation hasn't actually released a working LCD screen, and since it interfaces through the GPU, which is not an open design, it's really hard to make your own. But as a workaround, you can use the Chalkboard Electronics touchscreen. These guys are in Malaysia, and they basically They build a little LVDS panel which hooks up via HDMI and uses USB for the touch events. So that's a good alternative since there isn't a touch screen available for the Raspberry Pi. You don't actually need a touch screen. You can just hook up a normal TV or monitor. You can even hook up like a Windows compatible monitor / touchscreen. And then usually those will work via USB if you hook in the touch USB cable from those screens. That usually works as well. And there's a discount code. If you take a picture of that and tell the Chocolate guys, they should give you a discount off your order. Okay, and setting up your Pi is super simple. Install Linux. The Noobs installation works really good. You can download Java 8, download the final release, not the EA like my slides say. Then you can deploy and run JavaFX apps and hardware, and we're gonna do a demo again. Okay, so demo number 2. Okay, your turn's over, Duke. So this is a really cool demo board, which I got some help from Gary Collins rather, who works out of the Santa Clara office, and put this together as a sample for our Raspberry Pi and other embedded boards. Let's see where I need to position this. This should be good. And on the board here, it has an analog to digital converter, so that's how it interfaces. Let me get a closer shot. And it also has a touch screen on top. So this is probably what your desks look like at work, right? A mess of cables and wiring and all that stuff. Okay, so that's pretty good. All right, so you can see here is the Pi cobbler, which is just replicating the ports from the GPIO pins. I have a little LCD breakout board here, which is from Adafruit. It's just a kit they give you. The board here lets you interface via I2C, and then we'll control the LCD screen. And they added some extra buttons as well, and I'm not using those. Okay. And then we have a ribbon cable going over here to our breadboard, which has an analog to digital converter. This is a pressure sensor. So when we grab that, he's going to sense how hard we're pressing the sensor. And we also have some a light sensor as well on the board, a luminosity sensor. So this board is running Java SE embedded, right? We talked about the difference between Java SE and Java ME embedded earlier. And the rest of it's just a standard installation of the Raspbian operating system and all the usual stuff. Now to make it possible to hook up to this, I'm going to use internet connection sharing on my laptop, which looks like it's already set up. And this way, the Pi is going to get an IP address from the DHCP server, which gets started up when you do that. And I've installed Netatalk or Bonjour protocol on the Raspberry Pi, so that way we're going to see him as a device in the Finder once he finishes booting up. Okay, so good way to tell when your Pi is finished booting is there's a little LED in the corner here. which one shows power, that's the red one. The green one's for activity, and then there's 3 Ethernet blinky lights. And there we go. Okay, LCD test board. So we can hook up directly to them in the Finder, but I'm just going to hook up to them that way. Now you probably have guessed from the way this is going so far that I'm going to need a volunteer to help me out. But we need somebody who's really strong. So who feels like they can represent the strength of the French developer? Who? I heard somebody. David? In the first row. All right, well, I don't think you have a choice, David. You've been nominated to show the strength.
So what do we do?
All right, so here, have a mic.
Yep.
This way folks can hear you on the stream. And basically, once I get into the board, which is taking a seemingly very long time, then I'm going to run a program on here, and on the touch screen, it's going to show how hard you're pressing the sensor. So there's a little LCD screen here. Once we start the program, that will light up, and then when you grab the sensor, it will show how hard you're pressing it. And there's also a light sensor here. So this checks luminosity, so you're going to try to cover it as best you can to... operation timed out. LCD. Oh, he's not hooked up anymore. Oh, I lost my network. Okay. It's all coming together. Aha. Network. Here. Here. Aha. So when I was busy futzing on my table, I unplugged him. Most likely. Let us try again. Aha. There. Now we should have network connection sharing again. And hopefully this time it will let me log in. Blink, blink, blink. Password. Very good. We're going to run JDK 1.8, give it a jar file, and maybe that one. Okay, so now you see the touch screen is going crazy. Top says force, bottom says photo. And let's see, grab this, try not to yank it out of the board and see how hard you can. Oh, 14, 15, oh, 15, 30, 15, 33, 36. All right, good job, good job. Give him a round of applause. All right, so I tried this at user groups, and we've empirically tried this at about 20 or 30 user groups now. And so you're second strongest. Mm-hmm. There was one user group in Germany who got it to 1600. But very good. That was very impressive. Okay, now light sensor. Here's the light sensor. You just have to, cover it, and the second value goes down. Yeah. You can touch it.
Okay, I can cover it completely.
Yeah.
Oh, yes.
Okay. Yeah, that's better. 23. All right. Well, maybe you're too bright to.
Yes, myself. Yeah, there is light inside. Yeah.
Exactly. All right. Thanks very much. All right. Round of applause. Sticker, please.
Sticker.
Okay, so the demo I'm showing here, it uses the Pi4j library for accessing the sensors. So that's a great open source library. If you're using Java ME, we have a device access API that you can use to directly control the sensors, and eventually that will make its way into Java SE as well. But for now, Pi4j, which wraps wiring Pi, is a really good choice. So it's using the analog to digital 105 converter, a force pressure sensor, a photosensor sensor, all really cheap stuff, and a breadboard. You could put this demo together yourself without a whole lot of trouble. And it's a really cool example of what you can do with the Raspberry Pi and Java. So, other things you could try are, like I mentioned, the accelerometer earlier. I'll show that in the Duke pad. That lets you control things. You can directly turn on and off pins to control, like garage doors or other things at home. There's a whole bunch of other sensors you can use to detect entry or intrusion. And you can even hook up dongles to the Raspberry Pi, like USB dongles for Bluetooth or other things, so you can talk to other sensors like the Nike fuel band, which I had earlier. So I want to let Christopher?
Yes.
Christopher. I'm going to let Christopher talk a little bit about the Java Smart Energy presentation. So let's show your desktop instead. Voila.
Cool. Steven, it was I have some demo sticker for you.
All right, so I finally get one for my second laptop now.
Donc je vais vous parler d'une démo qui représente du smart metering et dans laquelle je vais vous expliquer une architecture qui a été mise en œuvre. Donc on a une similitude avec le projet Linky d'EDF qui va se déployer, qui est pour l'instant simplement en déploiement et en test sur 3 villes en France. Et l'idée donc c'est de récupérer toutes les données du compteur électrique à travers une architecture et les renvoyer donc sur le système d'information. Donc la démo qui est présentée n'est pas la même architecture au niveau software, mais dans les principes c'est la même chose. Donc si on veut rentrer en détail dans ce proof of concept, on va retrouver un compteur électrique. Ce compteur électrique, c'est un compteur électrique qui est fourni, qui est une référence implémentation de chez Freescale, qui fournit des démonstrateurs pour vendre ses microcontrôleurs. Et ce compteur électrique est connecté et dialogue en Zigbee avec des data concentrateurs qui peuvent gérer un ensemble de compteurs de 0 à 1000 en fonction de l'emplacement où il est situé. Donc par exemple, un data concentrateur pourra être mis dans un transformateur qui va alimenter un ensemble de pavillons dans un lotissement, ou il pourrait être enterré sur des poteaux électriques ou dans des bâtiments ou des tours. Donc ces data concentrateurs peuvent être de différents types, et le principe c'est d'avoir différents fabricants qui fabriquent ces data concentrateurs. Donc on va retrouver différents types d'architecture. On va avoir du PowerPC par exemple ou du ARM. Et l'idée, bien sûr, et l'intérêt, comme l'avait dit tout à l'heure Stéphane, c'est qu'on va pouvoir développer une seule fois l'application et la déployer directement dans l'environnement, peu importe le hardware qui tourne en dessous. On va avoir donc dans cette architecture 2 systèmes Linux qui vont tourner sur les 2 data concentrateurs. Donc si on regarde sur la partie hardware réelle, donc là vous avez un premier data concentrateur qui est un processeur PowerPC de dual core, et vous avez ici une autre carte qui est un autre data concentrateur qui est de type ARM. Donc il pourrait y avoir aussi une carte Raspberry Pi, ça fonctionne dessus, là j'en avais pas. Donc le compteur est connecté en Zigbee sur un des deux data concentrateurs. Donc ici on retrouve un coordinateur Zigbee. Dans le cas français, les communications entre les compteurs et les data concentrateurs, c'est du PLC, du courant porteur en ligne. Dans le cas de la démo, c'est du Zigbee. En fonction des pays, de toute façon, les moyens de communication entre les compteurs et les data concentrateurs sont différents. Donc l'idée, c'est de récupérer toutes les données du compteur, de prendre les données, de les structurer, de faire des calculs. Et ces calculs sont stockés dans une base de données embarquée qui est elle-même en Java dans le data concentrateur. Et puis, lorsque on va avoir à gérer un ensemble de compteurs et data concentrateurs au sein d'un pays, comme la France par exemple, il y aura environ à peu près entre 70 000 et même 200 000 data concentrateurs qui seront déployés. C'est-à-dire qu'on va ne pas pouvoir connecter directement ces data concentrateurs sur le back-end, mais on va avoir des sortes de head-end systems qui sont des systèmes qui vont gérer un ensemble de data concentrateurs. Donc, sur cette architecture, on a différents niveaux, différentes intelligences stockées sur ces niveaux, et on va retrouver en partie IT, donc intégré sur la partie fournisseur d'électricité, les gros systèmes, donc avec des bases de données Oracle, et des systèmes, par exemple, de WebLogic pour tout ce qui est application de serveur. L'architecture est découpée en fonction de son intelligence et en fonction des possibilités de communication. Donc entre le compteur et les data concentrateurs, ça peut être du Zigbee ou du CPL. Entre les concentrateurs et le head-end system, on va retrouver, c'est du GPRS, donc du protocole Light, on va retrouver du RESTful, dans le cas de la démonstration. Et entre les head-end systems, connectés sur l'IT, on va retrouver du web service. Donc avec du SOAP. Donc dans la démonstration, je vous montre que la première partie, là je ne suis pas connecté sur du back-end, mais on pourrait le faire. Et on va avoir différents éléments de visualisation. Donc dans un premier temps, on peut retrouver ici, écrit en JavaFX, une application qui pourrait être embarquée sur une tablette ou plutôt sur un device spécialisé qui est utilisé par l'employé EDF qui voudrait installer le data concentrateur, le configurer et voir ses performances. On va avoir un environnement de management. Le management donc, peut être fait via le web en utilisant un browser, mais aussi si on a un ensemble important à gérer de data concentrateurs, on ne va pas le faire à chaque fois avec du web, avec un browser, avec du HTTP, donc on aura du RESTful pour manager les data concentrateurs. Donc si je reviens sur l'application, donc là cette application représente les données donc, qui viennent du compteur, sont prises en compte, calculées, structurées, stockées en base de données, et l'application, elle, fait des requêtes en RESTful sur le data concentrateur. Et dans la partie supérieure, donc le trait et la courbe rouge représentent l'index de consommation depuis le début de l'installation du compteur. La partie bleue, c'est la consommation instantanée. Donc si je branchais un spot sur la prise électrique, on verrait que la courbe bleue montrait de façon instantanée. Et cette courbe bleue est calculée dynamiquement dans le data concentrateur, qui bien sûr a une application Java ici embedded. Et les scripts et les règles de fonctionnement du data concentrateur sont écrits en JavaScript. C'est-à-dire qu'on utilise le moteur Rhino, qui fait partie de la machine virtuelle Java. Dans la partie inférieure, on va retrouver des éléments de calcul, et ce sont surtout les éléments qui définissent la performance de l'application qui tourne sur le data concentrateur. La courbe verte, ici, en dents de scie, c'est memory usage. Donc vous avez ici à chaque point garbage collection. Donc c'est l'utilisation de la mémoire dans le concentrateur. Et les autres courbes représentent les temps de calcul au niveau de l'application, le temps de stockage des données dans la base de données, le temps de structuration des données. Donc par exemple la courbe rouge, bon, on ne la voit pas beaucoup, c'est le temps du JavaScript pour calculer la consommation instantanée des données qui sont prises du compteur. Comment se décortique cette application au sein de la démo? En fait, il y a un ensemble de composants, de modules. Donc l'architecture, elle est basée sur un framework modulaire. Donc je ne sais pas si vous avez entendu parler de OSGI. Bah, c'est pas OSGI. Donc c'est le même principe, dirons-nous, c'est un lightweight OSGI qui a été développé, donc que j'ai développé. Et à la différence de OSGI, c'est qu'il est distribué et peut dialoguer sur une architecture distribuée. Donc ces différents composants, ces différents modules, donc composent une application qui est l'application donc de relevé de données des compteurs électriques. Et on va retrouver en haut un scheduler qui donc va initier une relève. Dans le cas de notre démonstration, c'est toutes les 12 secondes. Et il va initier une requête sur un adaptateur, un composant adaptateur qui fait la communication donc, et qui gère la librairie de communication Zigbee avec le compteur. Donc toutes les 12 secondes, le scheduler va envoyer un événement au metteur adapteur qui, lui, va récupérer les données et les envoyer à un agrégateur. Donc ce composant-là va prendre les données et les structurer suivant un standard spécifique au modèle de l'énergie électrique. Ce standard qui s'appelle DLMS COSEM est dans le cas de la démonstration et dans le cas de cette architecture sous le format JSON. Et puis lorsque ces données-là sont structurées, on va les envoyer sur un autre module qui lui va faire du data processing et en même temps va appeler les scripts donc, qui sont disponibles et calculer donc, la consommation instantanée qui est en fait consommée sur ce compteur électrique. Donc on va envoyer en fait les données en JSON directement sur le moteur de Rhino de JavaScript. Ce qui est intéressant, c'est que le JavaScript et JSON, ce sont deux modèles qui vont bien ensemble. Donc le moteur Rhino va interpréter un script. Donc on peut avoir un ensemble de scripts, on peut pousser différents scripts sur le data concentrateur qui, bien sûr, n'aura pas besoin de redémarrer puisque tout est dynamique. Et à partir de là, une fois qu'on a calculé la consommation instantanée, on va reprendre les données. En même temps, on va rajouter des données liées au data concentrateur, puisque toutes les courbes dans la partie inférieure, vous avez vu que c'était l'usage CPU, le temps de mettre les données dans la base de données, le temps de faire des calculs. Donc toutes ces données-là sont intégrées aussi dans la partie données de JSON et stockées dans la base de données. Et puis dans la dernière partie, on va donc avoir les deux modules qui vont donc dialoguer avec la base de données qui est JavaDB. C'est la JavaDB Embedded JavaDB qui va stocker toutes ces données. Sachant que dans notre cas, la base de données JavaDB embarquée n'est pas un process séparé de l'application, c'est vraiment un thread de l'application. C'est-à-dire que là, on n'a pas besoin d'avoir une communication inter-process si on avait deux JVM avec JavaDB et avec la partie logique. Donc là, c'est une API qui lance la partie base de données. Et puis pour communiquer avec l'extérieur, on va avoir un RESTful Server. Donc de même, ce RESTful Server est lui-même la stack JAX-RS qui va pouvoir communiquer et fournir les données, donc notamment à l'application qu'on a vue tout à l'heure en JavaFX, qui donc fait des requêtes RESTful pour récupérer toutes les données. Donc c'est du RESTful avec du JSON. Et puis, de même, ce serveur RESTful, c'est directement l'API RESTful qui tourne sur la JVM Java SE dans une thread. Donc tous les éléments sont des API et des threads qui tournent directement sur Java SE. Il n'y a pas de serveur embarqué, sauf le serveur web pour l'administration, mais on n'a pas d'application serveur, on a tout directement, toutes les API qui tournent directement sur la JVM. Donc ça, c'est la partie architecture applicative. Donc maintenant, si je viens sur la partie administration, donc là j'ai un web server, et puis comme on est dans une architecture distribuée, donc le framework, je vous ai parlé un petit peu, c'est un peu une sorte de embedded cloud, et il sait détecter tous les nœuds qui sont et qui font partie du même réseau. Donc par exemple, là il a détecté deux data concentrateurs, donc le PowerPC qui se trouve ici, et le deuxième qui est une carte ARM qui donc tourne tous les deux du Linux, et on voit que l'une, au niveau de la définition des informations correspondantes à chacune des cartes, on voit le type d'OS, le nombre de processeurs, le type de plateforme et la charge, c'est-à-dire le nombre de threads par minute exécutées sur chacun des data concentrateurs. Ce qui est intéressant, c'est que je pourrais passer de l'un à l'autre pour les administrer, c'est-à-dire que chacun, il n'y a pas d'administration globale, chacun des data concentrateurs a sa propre administration. Donc je peux aller par exemple sur l'un des deux et cliquer pour aller me loguer sur un des data concentrateurs et avoir la liste des modules qui tournent sur le data concentrateur. Et donc on va retrouver la liste des composants qu'on avait vus juste précédemment, donc le RESTful Server, la JavaDB, le scheduler, les adaptateurs, et chacun de ces composants-là ont aussi la particularité au niveau de leur intelligence de fournir leur interface de management. C'est-à-dire quand vous développez le module et le composant, vous pouvez développer la partie HTML qui va correspondre au management, c'est-à-dire que l'architecture, au niveau web, il y a un méta servlet container et dynamiquement on va agréger les pages HTML de chacun des composants pour pouvoir les manipuler. Donc le développeur développe la partie logique du composant et aussi son interface. Donc par exemple, si je vais sur le scheduler service, ici j'ai la possibilité donc de voir les différents événements du scheduler. Et par exemple, donc j'ai les informations ici. Donc toute la partie inférieure est la page et l'élément servlet automatiquement agrégé et qui contenu dans le composant. Et on va pouvoir donc définir les données du scheduler, la date de début, la date de fin, la période, et appeler l'objet nécessaire pour faire cette fonctionnalité-là. Dans ce framework, donc toujours pour démontrer les possibilités de Java AC et Java AC Embedded, chaque composant en fait peut appeler un autre composant, mais pas sous une forme, je dirais Java, sous une forme plutôt d'URL, c'est-à-dire qu'à design time, vous allez pouvoir définir le nom de la méthode et le nom du composant à appeler, et vous mettez localhost. Si vous êtes en local, le système appellera le composant qui est en local. Si l'application est distribuée, non, pas dans ce cas-là, mais sur plusieurs cartes, eh bien, il y a l'équivalent d'un DNS, et dynamiquement, le localhost sera automatiquement remplacé par l'adresse IP où se trouve le bon composant, puisque l'ensemble des composants distribués dialoguent entre eux et connaissent en fait la configuration, comme un DNS, de où se trouvent les différents composants. Donc ça, c'était pour la partie administration de la partie scheduler. Donc on peut se promener sur d'autres composants. On pourrait aller par exemple voir le JavaScript Engine. Donc dans le JavaScript Engine, je vous avais parlé tout à l'heure qu'on faisait un calcul de la consommation instantanée en fonction des données, donc entre deux timeframes de données du compteur électrique. Et bien là, le composant de JavaScript Engine propose son interface et vous montre le JavaScript, donc la règle qui est en train d'être exécutée dynamiquement sur le data concentrateur. Donc là, je pourrais modifier le code, l'enregistrer et on prendrait en compte les nouvelles valeurs du JavaScript. Donc pour l'ensemble des composants, on n'a pas forcément toujours le même niveau de configuration, mais si je vais par exemple sur le composant REST Server, donc le REST Server a un avantage, c'est qu'il nous fournit la possibilité de faire des requêtes assez simples avec des get. Donc si vous faites un curl, vous pouvez obtenir donc les données du data concentrateur, les données du meter qui sont dans la base de données. Et l'avantage du RESTful, c'est qu'il est polymorphique. C'est-à-dire qu'en fonction du client, si vous avez un client de type terminal ou si vous avez un client de type browser, il va vous fournir la bonne réponse. On va se baser sur le format type MIME, mais bien sûr, il faut l'avoir codé à l'avance, mais on va voir cet avantage-là à travers une communication assez légère. Donc par exemple, si je clique sur ce lien-là, j'arrive sur la page et la requête RESTful help data concentrateur, et cette page, c'est simplement une page HTML qui me dit, voilà les requêtes disponibles que l'on peut faire en RESTful sur le data concentrateur pour obtenir des données. Donc c'est l'équivalent des requêtes qui sont faites par l'application qu'on a vu tout à l'heure, pour faire des requêtes sur la base de données dans le data concentrateur. Donc par exemple, je pourrais faire une requête d'avoir la dernière valeur du compteur, par exemple, ici. Donc, et je fais un Go. Et donc là, j'ai fait une requête donc, sur le data concentrateur. Je suis allé interroger la base de données JavaDB intégrée et puis il me renvoie les données sous forme de JSON correspondant au meter, son ID, le capture time, les unités et les valeurs. Donc ça, ce sont les données qui sont extraites de la base de données et qui sont mises au format donc JSON et transférées en RESTful. Donc on peut avoir l'équivalent aussi, par exemple, en faisant des requêtes RESTful, on pourrait avoir les données et les courbes donc dans un browser. Donc là, j'utilise de l'Ajax avec du JavaScript et je fais des requêtes RESTful sur le data concentrateur. Donc je récupère les mêmes données, simplement je suis dans un autre environnement et j'ai une autre façon de l'afficher. Donc ce qu'on pourrait essayer de faire, c'est récupérer toutes les données depuis le début. Donc là, je vais essayer. Donc je vais faire une requête d'avoir toutes les données stockées dans la base de données depuis le début et le démarrage donc, de l'application. Donc en résumé, on va retrouver donc, du Java SE Embodied qui va tourner dans différents types de processeurs. Et ce qui est intéressant, c'est que cette application-là était entièrement développée sur mon Mac. Donc j'ai développé tout sur le Mac avec du Java SE classique et j'ai juste fait du déploiement sur des Java SE Embodied, donc des machines virtuelles beaucoup plus petites en time de footprint. Et j'ai déployé de même façon sur le PowerPC et sur le processeur ARM la même application. Bien sûr, j'avais une JVM spécifique PowerPC et une JVM spécifique pour ARM. Vous pouvez les télécharger donc, sur le site de Oracle et vous pouvez donc travailler avec et faire votre propre application, de la même façon que vous pourriez faire ça avec un Raspberry Pi, puisque cette même application tourne sur du Raspberry Pi. Voilà en gros cette démonstration donc, qui vous parle essentiellement d'un domaine plutôt industriel au niveau de l'utilisation de Java, une utilisation qui est réelle, puisque même si ce n'est pas la même application, même si on ne fait pas du JavaScript pour faire des calculs dynamiques dans la réalité du projet DF, parce qu'ils n'en ont pas forcément besoin, vous avez cette application-là qui tourne déjà avec du Java. C'est un fait réel. Et puis, juste en dernier mot, si vous voulez avoir plus d'informations, vous pouvez venir me voir et on peut parler un peu plus de Java, Java 8. Merci.
All right. Thanks very much, Christopher. Would you, excuse me, would you mind grabbing Alex from the booth and telling him that it's his time to come and say hi?
Okay.
Okay. All right, so the next thing we're going to talk about is called the Duke Pad. So if you noticed me fumbling around on stage just a second ago, you might have noticed that our buddy the Duke Pad has unfortunately seen better days. The screen is slightly cracked, but still in functioning order. Let me see if I can get a good shot of it. Okay, so there's a nice picture of our cracked Duke Pad. Can you grab Alex from the booth? Yeah. Okay, where did I focus? That's about right. So the Duke Pad is actually, on the front, you can see it's an LCD screen. It uses the same screen I talked about earlier, the chalkboard electronics screen. But on the back, let me use this laptop as a stand. Okay. On the back, you can see the internals of the DukePad. So on the top left-hand corner you can see the Raspberry Pi. In the center is the Pi cam. So we talked earlier about the Pi camera, and you can see it sticking out there out of the hole in the back. You guys should swap mics too. And he's going to need both of them as well. So mute them before you take them off so they don't make noise. You can see on the back there is also an accelerometer. So that red one in the center is the same one I had on the slide. Normally there's a battery attached to the DukePad so you can actually use it kind of like a tablet. But I've replaced that with a screen splitter. So that way you guys can see the output from the DukePad without me attempting to focus the camera perfectly. USB hub on the right-hand side. And what else do we have? Normally there's GPIO pins there as well, so we simply put a port extender, and you get little serial port outputs. You can plug in a serial cable to access GPIO pins. But currently that's where my extra cables to power the hacked HDMI splitter are hanging out of. So one of the advantages of this is, unlike a consumer tablet like this guy, which we'll talk about in a sec, if you open up one of these, you void your warranty. The DukePad you have to open up. That's a requirement. You have to build it yourself. So it's much more fun than just buying a tablet off the shelf. All the parts came to about, I think, $300 or $400, including the accelerometer and all the little components. It's fairly cheap, everything you can buy off the shelf. The only thing which requires kind of a little custom engineering is the actual case itself. So the case is laser cut, and you probably don't have a laser cutter at home. But your city probably has a tech shop or a maker shop, workshop, or someplace where you can kind of like borrow or rent one. So basically what we did is Jasper, who's the demo guru, lives in Santa Clara, and he went to the local tech shop. So you have to take some classes to learn how to use the equipment, and then you can sign up and rent it for a few hours at a time. So we laser cut about, how many of these did we make, Alex? All right, so come up here, Alex. We have to introduce you properly. We're doing the DukePad segment, so this is, you're also going to chat about some other stuff, but this is part of it. Okay. So Alex, I can't say your last name. Kozetsno?
Good try. Just Kuznetsov. That's okay. Russian.
But he's on the demo team, and he worked on building the DukePad and the chess demo, which we're going to chat about in a sec.
So regarding to your question, I think we were going to make 16 or something, and I think we end up doing 6. Maybe 7, I don't remember.
We had lofty ambitions to mass produce the DukePad, and it turned out to be a lot more work than it was cut out. But yeah, this is something you can hack together yourself. Now, a little behind the scenes on the DukePad. So this is the 3D rendering of the DukePad with the components in it, right? Here's the actual laser cutter. So Jasper took a picture. Basically, you get these big plastic sheets, plexiglass? Yeah. And then it'll etch and cut through the laser, and it cuts through kind of a paper backing. And then you peel that off, and you get clear plastic, which you can then stack up in layers. So basically, the DukePad case, it doesn't require fancy 3D printing or anything like that. It's basically just you take out the sheets, you stack it up, and then you bolt it with attachment points around the edges. Some of the components: USB hub, LVGS connector, battery. Here's the thing of the Duke pad with the attachment points on. And then partially assembled, more assembled, even more assembled. And oh, there's Gary. So he's the final member of the demo team. He couldn't make it out to France, but he says hi. And then finally, that's the website where you can find out more about the Duke pad. So we're gonna attempt to demo the Duke pad now. Are you gonna help me with this, Alex, or I do this myself?
Sure.
You want to cut your fingers?
Why not?
All right. Well, I can cut my fingers if you'll talk about what we're showing.
Okay.
Okay. So hold on.
Does it work?
It kind of works. All right.
So you may want to rotate your camera.
Yeah, that would be good.
I don't know how to operate it.
Okay. So there's the Duke pad screen output and a little picture of the Duke pad.
What happened to Duke pad, by the way?
Yeah. So Duke pad did not like being dropped out of my motorcycle case.
Oh, okay.
But, you know, he did pretty good. Like, he made it
Twice?
through like 20 events.
Oh.
And then finally, which city was I in? I'm losing my mind here. No, I can't remember the city. But then
Wow,
be
it
careful with
works.
that. You don't want to rub your finger across. But you can like trick it. Okay, now we're locked in. If you rub your finger on some of these areas, you'll pick up glass shards. Okay, so now we're logged into the Duke pad. That's not cracked up there. So at least you guys get to see what it looks like. Okay. 3D?
Uh-huh.
So
Oh.
all of these apps are deployed as OSGI bundles. You going to talk more about this?
Well,
3D.
yeah.
This is new in Java 8, right?
Yeah, this is done in JavaFX, JavaFX 8. And this was a part of the Java 1 demo. I think it was Java 1 2012,
Wrong year.
which was
Oh, this 3D demo, you mean? Yeah.
Yeah,
Yeah, okay.
and that was just, I thought there was a key to start the demo.
A key?
Oh, doesn't matter. There is no
Oh.
keyboard.
Yeah, there's no keyboard. Okay. So you any good at this game? Are you any good at this game?
No.
No. Basically, it's a JavaFX game, and you have to try to match stuff up. Oh, I need more bombs. I can only win when I have bombs. Actually, matching stuff is painful and slow.
Oh, you're swapping pieces, right?
Yeah, you just swap the pieces to. Come on, let me win. All the people at DevOps France are watching, and you won't give me enough matches to win. Oh, what's the question?
Operating system?
Yeah.
Yeah, okay, so you want to answer
Go
this?
ahead.
Yeah, so it runs. Okay, so the question was, is there an operating system?
So what is the tablet or Duke pad actually running on? Is there an operating system behind it? And you spoke of the OSGI, so how is all that related?
Yeah, so the Duke pad runs Raspbian operating system, so it's Linux, the standard Raspberry Pi Linux operating system. When it first boots up, it's set to load the JavaFX front end as the tablet UI on boot, and the JavaFX wrapper application will load a bunch of applications. So each of these applications, like this game, is loaded as a OSGI module into the JavaFX application. So then you can deploy new applications, like if you run Android or iPhone, you deploy as like an APK or an IPA. In this case, it's just a jar as an OSGI bundle, and you drop it in. You can deploy new applications right to the device. So really easy to get started with. Oh. Okay, anyway, that's enough of that. So that's a game you can play. One of the things which the DukePad and the Raspberry Pi are really good at in general is playing media. Oops, there's some photos. And let's see if we can play some movies. So besides having a fairly wimpy processor, the Raspberry Pi has a really good GPU. So it can play back full frame H.264 encoded video. And anyone here run XBMC on their Raspberry Pi? Okay, so you guys all knew this already. You're using it for that purpose in your home media center. And you can do this with Java we're stacking frame buffers. So it's a JavaFX user interface, which is transparent, layered on top of a native video rendering frame buffer. All right, so what else should we say about the DukePad, Alex?
Well, there were other apps that we were going to develop, but that we didn't finish them in time, like that little compass.
Yeah, well,
And
the apps you guys did develop are pretty good. If folks want to, what are you going to do?
Can you run a chess demo?
Well, it's not on the network. So it needs a chess server, right?
Oh, yeah.
Yeah, that's why I didn't open that one.
Okay. I'm a chess demo guy, so.
All right, so speaking of the chess demo, I think that's a good segue to talk a little bit about the chess demo. So if you guys noticed that when you're coming in the room, there was a big chess robot sitting outside in the Oracle booth. And we actually brought that here to Devox France specifically to show off Java embedded technology. And I believe that's actually running Java ME.
Yeah, currently it's running Java ME, but
It runs Java ME or SE. You have two versions of the software.
we have two versions, yeah. But for headless mode, we usually run Java ME, and for development calibration, we have an SE version, which was the one that we started with to develop a robot controlling stuff. You want to switch the slides?
So this is some of the early designs of the chess robot.
Yeah, there was different random ideas when we were thinking of creation demo for a conference. Let's move to the next slide. Yeah, and then we have a nice video that's showing many steps of creation of this robot. Do you have it?
Yeah, we have the video. I'm not going to attempt to play the sound because it won't come out.
Yeah, I usually play it at a half speed or a quarter of speed, so guys have a chance to see at least something. But yeah, there is a lot of work behind this thing.
So all the 3D pieces, initially you guys injection molded them, right? And then later on we 3D printed them? What was the final one?
Chess pieces,
yeah,
right?
chess pieces.
Oh, all these terms, I don't know them. But yeah, we 3D printed at professional 3D printing laboratory or something. But yeah, we tried to print ourselves. If you know, if you notice, there were some moments where we were printing like this, is printing Duke.
Yeah.
Can you pause somewhere?
Yeah, we can. This was the molding process, but I don't think we actually, you guys didn't end up using the molds for the final version because they didn't come out.
No, we exactly used them. So let me talk about this a little bit. So here is the 3D printer, and if you notice that, well, it's hard to see there, but that's a Duke that is coming upside down, and it's instead of head there is a flat surface, so then you can attach head on top. So in order to print stuff in 3D printer, it generates a lot of supporting material, and here you can see like this vertical bar is a supporting material for the model. Well, in general it works, but the end result is not that smooth and nice. So that was us printing, and this is what professionals did for us. So that was our set of 7 pieces that we had to use like copy and paste in physical world to create a set of pieces for the chess game. So yeah, and here is the tedious process of doing that. So it had a lot of issues, but yeah, and Jasper Potts, who is the father of this demo, he did a lot of work in order to mass produce these pieces. He took classes to learn how to mold. So basically you create stuff like this gel or something. What is it? Do you know the name of this material?
Isn't it like a
silicone? Oh, it's probably
Yeah.
silicone.
Yeah.
So yeah, he created these pieces. Oh, that was a good spot. Is there a way to to slow down? Like double rate? No? Or move like frame by frame?
That's fast forward.
Okay, doesn't matter. So anyways, yeah, there was a lot of work involved. But that's not related to programming, right? So we probably should continue with the slides. Yeah, so our goal in this demo was to showcase all 3 technology. I mean, Java SE, Java ME, Java E working together. And yeah, we were going to use a Raspberry Pi as a platform, and we found some good source of hobby level robotics. And yeah, this is our original concept of the robot. You may notice that in this model it had just one gripper, this little thing here, which is used to pick up and drop pieces, and there is nothing on sides of the field. That was really funny that when like the designer originally thinks about stuff, he does not like think how to capture a piece, where to put it, and how this all should operate. So if you noticed on that robot table outside, there are 2 grippers. So when you pick up a piece, you can like swap them and pick up another, and put the one that you were attacking with on that position, and then remove the piece. So
I think it's obvious when you realize that you play chess with 2 hands, but not obvious when you're trying to initially design something like this.
well, actually, good players I think do it with 1 hand, but it's still, yeah.
Well, okay, so the chess robot does that too. It has grippers on either end of its arm.
Yeah, there was a design to make them at like a 30 to 45 degrees angle, but yeah, we did not get that far. When they are opposite, this is balanced construction, so it has less problems. So we started from Java SE, so I think it should fit into this topic of Java SE 8 world. So what we did first is we created a 3D model on the right. This is rendered by JavaFX, a 3D model, and we started to play with it, like think about how we're gonna control it, and everything was pretty simple at this stage. Well, there was some trigonometry to solve, some tasks, some tasks like that, but yeah, we've got this column of 8 values which determine the position of the robot at any moment. We got the 3D coordinates of a point in space where gripper is. So, well, pretty easy at this stage. So everything was doing fine in this 3D programming world. Yeah, I don't know if I need to cover web client or DukePad client.
Yeah, so the physical world wasn't exactly the same as your little 3D program, because I remember there were many, many weeks of frustration.
Yeah, so when it came to a physical world, everything was much, much worse. Let me skip it for now, but yeah, this is also other JavaFX-based versions of Chess Client, and then this version we had animated 3D pieces. Do you think we can find it on YouTube, the video, how they behave? Because I don't have it running at the moment.
Which one? Jasper's video?
This video from Java 1.
Yeah, keep going.
Yeah, okay. I'll show it later. And this was the simplified 3D version of a client for DukePad, which had no sophisticated animation. A client for web. So far so good. For ME version, we used Java ME version 3.3, I think .1, and the idea is to reuse as much code as possible. So basically, all the logic of robot movements and like pretty much everything was covered and shared between SE and ME. Cool. And there were some interfaces that were implemented differently on SE and ME, and I think those are mostly related to low-level stuff like controlling.
Okay, you want to show the video?
Controlling devices. Yeah, why not?
All right, so you have to narrate it.
Well, actually, this is the robot video. It's not the one
Oh, you want the 3D
I was
client
looking
video?
for.
Okay, well, you can narrate this one instead.
Yeah, can you find another one where it? I think it's Java 1 keynote video.
All right.
Okay. Can you switch back to mine?
Yes, sir.
Thank you. Cool. So yeah, the power of Java is that you can write software in SE and then use it in ME pretty much without changes, especially if you cared about some details, not using some API that's not available on ME at that version. So yeah, an ME version of this robot had a telnet interface, so in order to control it, you had to connect to it and send text comments. But in general, that did the same thing. When it knows what to move and where, the code is the same. It just executes the same code. So you want
Alright, let's
to
try
found
again.
that? Okay.
I found a new video.
Yeah, so that was the 3D one. Oh, poor quality. This is running JavaFX 8. All the standard API. There is a project called 3D Viewer.
Yeah.
So 3D Viewer project is an app where you can import different 3D formats, and we were primarily using Maya, which can contain animation, and that animation is converted into JavaFX calls. JavaFX structures, timeline, and animation, and you can play back it. So we had a professional animator created for us these Maya animations for different pieces, and there was some magic done on our side to swap heads for them and to rotate them and move to the right position, and yeah, playing those animations. So yeah, you already done with this, right?
Yeah.
Should I cover
No.
E? No? Okay.
You guys are already server-side developers, so we don't need to teach you Java EE.
Yeah, so I think
There's a Java EE client that, or a server rather, that runs behind the game and handles all of the chess moves and stores games and et cetera, et cetera.
yeah, so basically we had a server, and with these simple JSON messages, players were sending moves to the server, and server was communicating them back to the players, and our chess robot was one of the player, and he was just repeating the moves. So coming to hardware, this is I think pretty much list of all components of our chess robot that you can see outside of this room. And let's see what are those. So Raspberry Pi, the heart of everything. Some connecting things. Is it cobbler?
Yeah, it's the Pi cobbler.
Yeah.
We showed one of them that's on the board right here.
Yeah, I have a better picture in the next slide. Then for the lighting beneath the cells, we had this LED strip, which actually supports any color, I think. Yeah. And this thing we used as a servo controller, but originally that's LED controller. Still works. Yeah, so those are servos. And this is how you connect everything when you are just starting. Easy way to develop this
It's
part.
a mess of wires.
Well, yeah, for us it is, but for the special hardware technician, it's all simple and clear. Yeah. Yeah,
It's the
again,
LED strips.
for pictures of how it's all created. It's a Jasper Potts doing manual coloring of this black ink on top of the white plastic. Yeah. So that's just some random shots from this development process. And the thing that became obvious to us after we started this project is that whatever you think is easy and doable in 3D and in like logical and I don't know how to say it, in a software world. When it comes to physics and physical pieces, it all goes really, really weird. So you can see different charts that, well, they were showing that, yeah, a lot of problems. Like sizes, like if you should know the size of your hand in order to position it correctly, but you cannot measure it if you don't have a special costly tools. Well, it's hard to measure, and when, for example, temperature changes, the size changes again, so not too good to measure. Angles are completely nightmare to measure. So yeah, all of this happens. I don't want to cover all of this, but 90 degrees is no longer 90. So if we go to a table and look at it, so on the right image you can see that it was bending down like this. Now when we glued all the parts at the sides and put a support underneath, it pops up when it is heated with the light. So a lot of complications. And 3D printing almost always was bad. So anyways, yeah, I think I concentrated too much on the problems, but maybe I need to talk more about the way it currently works. So who knows how many servos we have in our robot? 4? Other guesses? 7, close, very close. 8, right. So we have 4 to control the position of the arm. So rotation in this, how you say that? Yeah, it's not horizontal, but yeah. So yeah, I agree, horizontal. Then we have 3 that are moving the hand up and down, and then each gripper has to rotate it and close and open. So that's 8. And how many sensors do you think we have in the robot? And what kind of sensors? No. So, yeah, that's. Yeah. So, do you think we have it? Do we have touch sensors? No idea. Okay. So actually, there is no sensors like touch sensor at all in this construction, and each servo. This is not the servo we are using right now. We use a better one, but each servo inside of it has a sensor that detects its current position, rotation, current rotation. So the way you control this servo is you send a wave of a specific length, and that length determines angle, and there is some sort of processor inside, microprocessor inside the servo that keeps that position. So there is a sensor that senses current position, and if it deviates from that, it turns on the motor to return back. So that's how it can be hanging. So it is never kind of still, it is always working, even because there is a weight that is trying to put it down, and the sensor is sensing that the motor deviates from the right angle, and it turns on the motor. So that's the way it works. So coming back to Java and how we operate with it, We have a API that we can control this thing in the middle, this LED controller. We can set the length of the wave for each particular channel, and we have 8 channels here for each of the servos. So we set this angle, and that's it. That's all we can do. And what happens next? If the angle that we set to the robot is far from where it was originally, then it will hurry at a high speed moving to that position. And if it's very close, it will slowly move. That's how servo work. So our approach was to use timing and some notion of the current state to determine how much should we wait before we can assume that we got into the position. So yeah, so that's how it is currently works. Some tricky thing here is that what was I going to say? Yeah, so you never know what is current real position of the robot, because there is no way to read the data from servo. You can only write to it. So, and the servos themselves, they are quite powerful. So if you say something like move down through the table, it will do it, and there is a big chance of something broke this movement. So we broke a lot of details and parts. So we burned one servo. So yeah, finally we figure out some safety measures. We have a lot of code that stops, like if you program something incorrect, there is a ranges that will limit each servo, but even with that you still can get into trouble. That's why basically this robot requires attention from an engineer who developed it, because otherwise, yeah, it is really easy to break it. So anyways, we've got no eyes for our robot. It just knows how the servo is rotated, and then we calculate positions for each cell, and we assume that we can get into that cell. Well, that's not true in real world. You can get in a random area of that position due to some hard to measure things like angle is not exactly right, length is not exactly measured right, or something happened to the sensor that measures the angle. So, well, we end up with a calibration process. And that calibration process is basically, once you get into a position, you look into it and add corrections to it, and then saves them into a file, and here you go. You have positions for all the cells, and yeah, and it works. And you can see it outside how it works. Yeah, here is a slide where we were calculating how much error will we get at the end of the arm if we are not accurate enough. So 1 degree of inaccuracy gives us 2 centimeters of height difference. So,
and it gets worse as you go to the extremes of the chessboard, right?
Yeah, I think it's calculated for the extreme.
Yeah.
But yeah, we noticed that there were 2 extremes. One on the more distant part of the table, and another was
right next to the...
Yeah, very close. It was really, really bad in that area. So, were there anything else? Yeah, for those who are interested in how big this software that we've created for the robot, these are some numbers. So, yeah, you can see that Java ME only code is 700 lines, and that's pretty much just implementations of parts that are specific to devices and this telnet protocol and stuff. And this 3000 on the top is a shared code, and 2000 lines, I think it's JavaFX 3D stuff.
Okay.
Yeah, I think I covered this. So this is a graphical representation of the actual numbers that correspond to different cells. It's hard to understand what it means, but that was my attempt to find any dependency between real values and the cell on the table. But you can see that there is no obvious dependency, like the line has ups and downs and whatever. So those are all different. Each point represents individual cell on the board. So these are X, Y, and Z coordinates of it. All right, I think that's pretty much it.
Cool. All right, so if you want to find out more information about the chess robot, we're going to be doing a BOF tomorrow night to go into more detail about that. Thanks very much, Alex, for dropping in.
Thank you.
And so now I promised that I would show you Java running on a few unusual places. The first one we're going to show is Java running on consumer tablets and devices. So anyone here have a iPhone or Apple product? Okay, now keep your hand up if you're running Java on that. Okay, all the hands went right away. Yeah, so we want to fix that. So first of all, you may not actually know whether you're running Java on it, because there's a bunch of apps in the App Store which are using Java and they don't say they're using Java. And the second thing is, as a Java developer, there's no excuse for not playing around and hacking your own apps in Java. I mean, that's the easiest language. You don't need to learn Objective-C, and it's quite straightforward and easy to do. So I've got a iPhone here, and happen to have some Java apps running on it that I'm going to show you quickly. And it's really, really easy to do. So basically you take RoboVM, which is a cross compiler for Java, and that will compile your Java bytecodes into native code for the device. JavaFX or OpenJFX is the user interface. And then you can use all the Java class libraries, use Java 8, use OpenJFX for your visual user interface, and then you compile it using the IS toolchain into an IPA file you can deploy to device. Now, like in order of complexity, getting a simple app built, that's easy, right? And I'm using one of the sample apps. Using RoboVM to compile for iOS, that's relatively easy. It'll take you like an hour to get it set up and get it hooked into Xcode if you don't have the command line tools installed, but fairly easy. Getting Apple's toolchain to let you deploy something. If you haven't tried it before, easily you're in for a day or two of pain. But I've done this several times in past lives, and it still took me a couple hours to refresh my certificates and update my Apple developer program and get Xcode to have the right certificates and get everything set up. It's just, they make it wonderfully easy for developers. End users, great, easy to use. Developers, sorry. Okay, so let me show you guys an example of a real application running on an iPhone. Okay, so. And you can see the startup time is fairly quick. And here's the fish sim application. Yeah, fairly good performance. Easy to use and play around with. So against better judgment, I'm going to pass my phone around the audience, try to find the way to make it back to the front of the room. And it would be rather humorous if you went and you tweeted or blogged stuff from my phone from the session, but try not to do that. Okay, so next device we're going to show is, actually, before that, okay, and then, like I mentioned, there's a whole bunch of apps which are already using Java behind the scenes. So there's a few, 2 or 3 dozen apps already out in the App Store that the RoboVM guys know about and post on their website. Undoubtedly, there's even more people using it who just don't credit back because there's no reason why, from an end user perspective, there's no JVM to install. There's no special process. It looks like any other store application in the App Store. So you don't even need to know you're using Java under the covers. So before I move on to the next device, are there any questions about iOS development and how it works and App Store restrictions or anything like this? Yes.
You have to write all your code in Xcode, or you can use IntelliJ or something else.
Okay, all right. So the question is what IDE you code in. So that fish sim example I showed, I did that in NetBeans, and there's a really nice NetBeans plugin that it sets up all the tooling for you and integration with RoboVM. It downloads RoboVM as a Maven artifact, so you don't even need to download RoboVM separately. The Maven script just sucks it down and builds it for you. And there's good Eclipse support for it as well. I believe that's what RoboVM mentions on their website is the Eclipse plugin. I don't know about IntelliJ support for RoboVM, but I'm sure you can do it. I'm not sure if they have a special plugin yet for making it easy. And from a Apple toolchain perspective, you don't actually need to ever open Xcode other than to make sure that you have the right certificates and you have the command line tools installed. But beyond that, it does it all from the Maven build script. Okay. Yep.
My memory is good. It's quite similar to what has been done by Adobe. At the beginning, they try to transform Flash or Air into native code for iOS, and at the end they forget it. They give up this kind of solution. I don't remember if it was for fight with Apple or some.
Yeah, okay, all right. So let me repeat the question, and then you can add stuff if I didn't get it right. So he was mentioning that several years ago, Adobe tried to do the same thing, right? They tried to let you do cross-platform application development using Flash and Flex.
And the question is it really a good solution? Can we leverage on, or maybe we face to the same kind of...
Yeah, so the question is, are there issues with Apple deploying apps to the App Store? Okay, so I know a little bit about this because I wrote a book called Flash on Devices, and it got published and released in the US on the same month that Adobe pretty much killed their mobile Flash story. And what happened with the Flash stuff is initially so Apple had remember Steve Jobs sent out the nasty blog entry slamming Flash. They actually removed it. They restricted you from having in the App Store any third-party frameworks. And initially they had something in their license which said it had to be written in Objective-C. And And that's what made all the press and announcements. That's what everyone heard about. But what most people don't know is a couple months later, they actually changed it again, because that precluded all the third-party frameworks and things which iOS developers were already using. Like most games, if you use games on iOS, they're not actually built in Objective-C. They're built in OpenGL plus some third-party gaming framework that then runs on the device, and that way they can support Android and iOS and a whole bunch of different devices. So they backed out and they said, no, we didn't actually mean you have to do it in our tools. We meant you have to just have no dynamic library, no dynamic code compilation. So basically it precludes you from running a just-in-time compiler, or in the case of Flash, that meant that their solution was actually fine since it was interpreted. So a few months later, when they actually allowed Flash back into the App Store, that never made the headlines. And similarly, there's nothing precluding you from running Java on the App Store. There's already plenty of examples of folks who are doing this. Although, just legal disclaimer, like the Apple Terms of Service is a book. Like if you've ever seen the agreements, so there's way more legalese and stuff in there than I would ever personally be able to read and understand at a fine grades level. So, if you work for a big company and you're going to make billions of dollars on your app, get a lawyer. But if you're just a Java hacker trying to build apps for the device, chances are that it's, as far as I know, perfectly fine according to their terms of service, and there's plenty of folks who are using Java for apps. Okay, so the second one I wanted to show you guys is the same thing running on Android devices. So I have a couple Android devices here with me. We have, anyone recognize what this guy is? Yeah, okay. Someone said ASUS Transformer. And did I give you a sticker? I owe you a sticker, don't I? Okay, so we'll get you a sticker. And I have another device here as well. So this is a smartwatch. It's not the one you guys probably heard about, this Samsung Gear or whatever it is. This is the ZG Pax, very finest China Android watch. It actually has a faster processor than the Samsung one. But the technology is just getting to the point where you can actually have really tiny watches. This actually is a phone, and you can do voice conferencing on it, and it runs Android applications. It is everything except a good battery life. But the technology is getting to the point where you can really get the stuff to be wearable. That's one of the big new things is wearable computing. All right, so boop. We've got our Android tablet. Now, if you've watched any of my lambdas presentations, you'll know that there's a little game I use called Merry Hello Lambda to teach the streaming API. And it runs really nicely on Android. So basically, the way this is working is it's using the Java code's running in the Dalvik virtual machine, so it's not a separate virtual machine you're installing. And it's, again, using the OpenJFX library, so it's portable. You could have the same application running on iOS and running on Android and running on desktop. Because this is a Java 8 application and Android only currently supports Java 1.7, this is using retro lambdas to get you lambda support in 7, but you get the idea. Okay, bye-bye sheep. Now we have our eggs. So that was a map, and now we do a flat map, and we get our chickens. And finally, come on, happy fox. Okay, so the performance is really good. It runs like, orders of magnitudes faster than the Raspberry Pi. Even though this game runs fine on Raspberry Pi until you get too many animals One of the things that I also do workshops for DevOps for Kids, and the kids, they love to just go back and forth and like get more animals and more animals and more animals. And eventually, you either, run out of memory, which happens on desktop, or the application gets so slow it's unusable, which happens on Raspberry Pi after a couple loops. On Android, it runs out of memory first, so it's reasonably performant. Okay, and then move over. Oh, there's our cracked Duke screen. Still hanging out. Okay. Maybe if we position this on a fixed surface, it's easier to do. Okay. Looks fairly good. Oh, it thinks it's sideways. All right, there we go. And now it's in some weird... Come on. So apparently I can't use this device. There we go. Okay, so I have an application, a JavaFX application here that was designed by Garrett Grunwald called Clock2. And basically it shows the time as words in various languages. So that's, German. And you swipe down, and now we have English. Vor. Is that French? We found French? Okay. All right, so you can pick your language, and then you can, get it in words, or you double click and you switch it between words and time. You can swap to get different colors. So it's a lot of fun. Same thing, I'm going to pass this around. Please make sure it makes it back up to the front of the room. I would pass around the cracked Duke screen, but that would be a liability. I don't want to get anyone hurt. And we'll also pass around the Android tablet. Ugh. Okay. Hopefully that's close enough. All right, and just to show you a little bit about the technology running behind this, here's the project page for the Android port. So Johan Voss is the project leader for this. He's also on the DevOps program committee. So he's a DevOxian. And they're trying to continue to work on the port. The port was originally developed in Oracle, and we open sourced it as part of the OpenJFX open sourcing last year. We don't we don't offer commercial support for this, so it's up to the community to take things forward. So in the case of iOS, RoboVM as an organization is supporting it, and in this case, there's some folks in the open source community who are supporting it, and they're adding an additional support for Android-specific sensors and things which are specific to the tablet UI. Hopefully they're going to fix the rotation bug, which you'll notice if you play with the tablet. It doesn't really rotate properly. So, good effort from the community. And our last topic of the day is the Now Robot. So, I'm going to show you guys this little guy over here who's been hanging out the whole presentation, just kind of waiting for his turn. So the Now Robot, you guys should be quite familiar with, since he's actually made by Aldebaran Robotics here in Paris. And he's a humanoid robot. Did I forget anyone who deserves a sticker? Okay. That was a chance for you to get a free sticker in case you wanted to be slightly dishonest. Did you get one already?
Yeah, I already got one.
You already got one. Okay, there aren't that many left, so let's give it to somebody who hasn't had one yet. But I think you did answer several questions, so you probably deserve a pile of stickers. Yeah, so there's our buddy the Now Robot. The cool thing about the Now Robot, yeah, so that's a demo test of the rectangle performance on the Raspberry Pi. Yeah, so there's some other random apps on there as well. Some that require internet connectivity, so those might not work. But that's basically my demo device or hacking device. So there's random things on it. Okay, so right now the Now is running a program called Now Life, and basically what this is it gives him a little bit of human interactivity by having him move around. He's listening for noises in a very noisy environment, and he's also trying to track faces. So once he sees a person's face like mine, he'll start kind of following around and trying to look towards you. You notice he also naturally looks up because he's assuming he's on the ground and he has to look up to find people. On his head here, this is a tactile sensor, so you can touch this. And he knows which area part you tapped on. The eyes are LEDs and IR sensors. There's 2 cameras, a forward-facing and a down-facing. They also use this for soccer or football, European football. You guys have to call it American football, so.
No, it's football in Europe, it's soccer.
Yeah, I know. In the U.S. it's soccer. And we have American football in the U.S. But soccer is really European football. So they use these guys for European football contests. And that's what the down-facing camera is quite useful for. He also has on his chest, he has some IR, proximity sensors. So he can tell if he's near something, he's going to bump into each other. Also, these little bumpers here, one of which fell off, and if you notice, I was slapping back on in the middle of the presentation. He has about 26 motors throughout his body, and these hands act as grippers. So they're single grippers. They can grab and release, but they can't individually articulate. Also, some of the joints are kind of interesting, like the pelvis joint. Both legs only rotate together, so he can't individually rotate his pelvis joint. But they made some interesting trade-offs to get all this to fit into a rather small body. What else? He has speakers, a microphone, and yeah, he doesn't like when I poke his microphone. And, stuff. Okay, so there's 2 things which I'm going to show you running on him. One is I'm going to start with the Choreograph software, which is a nice visual programming environment, but, we're Java people, so we also want to show Java running on the Now as well. So Choreograph lets you do kind of box modeling and run simple programs on the Now Robot. It's a good way to get started. It also lets you look at the camera output, see what the current position are, and it has a nice animation mode where you can do custom animations. So let's see if we can't hook up to the Now Robot using Choreograph. Okay, so our Now's name, thanks to Sharath Chander, is Quava. Okay, now we're hooked up to him, and okay, so he is not going to get any face detection with those bright lights in his eyes. But you get the idea. So that's what he's currently seeing in the audience. And then on the left here, there's a bunch of boxes we can drop in to do different stuff. Like it might be nice if he was standing, and then you wire this up to the start, and you play it. This will immediately execute on the robot, so once he gets the command, he's going to go ahead and do whatever we told him to do. Okay, one of the great things about the design of the Now is they did a fairly good job of making the housing sturdy. So it's actually quite hard to break him. But I think we did. Good thing we're in Paris, because I can get him repaired, hopefully. Let's see. Ah, yes. So this actually looks not to be completely damaged. So he's probably repairable. Now I've removed the stablers on him, and we can see, oops. But it appears none of the parts actually got damaged, and none of the cables got ripped off. So he is probably serviceable, but he probably won't be dancing today. It's my guess. Okay, so here's what we're going to do. Come on now. Probably because the table was not level. So a lot of the animations on the Now robot depend upon being on a fairly level surface. And this table, as you saw from this guy shaking around, is not the most stable level surface. Okay. So we are going to pick actions for our buddy Now, which don't require him to stand. How does that sound? Come on. Okay. He's doing a yoga dance. All right, so yeah, no need to stand up now. You can hang out and sit down. Okay, so let's switch to Java. And so one of the things which we can make him do while sitting is he can speak. That's easy to do, right? Let's see, his IP address changed. And here's a real example of the Java programming API hooking up to the speech service. Hello, Devoxians. How do you like French baguettes? Oh well, it's close enough. All right, so let's give this a try. Okay, so we're going to make him louder. And Alex, you still have your mic? Grab your mic. The room mic is more important. Okay, his it's the ear which makes noise, not the mouth.
Oh, okay.
Unlike what you think. Are your mics turned on or are they off?
On.
On. Okay, let's try it again.
Hello, Devoxians. How do you like French baguettes?
Okay, pretty good. Now, wouldn't it be cool if we could get him to say that in French? So if we log into the actual Now itself, did I get the right IP? 4? Thank you. Yeah, so the choreograph software comes with a robot when you get one. As does, they have WebBots, which is another program you can put kind of a virtual environment to test out the Now. and of course the APIs for other languages. So you can use Java, Python, and a bunch of different languages to control the robot. 10, 0, 1, 4. Okay. He does not want to say hi to us on his port. That's fine. Let's have him take a picture. So, we're going to have the Now robot take a picture and then put it on screen, hopefully.
I'm going to take a photo. 1, 2, 3, smile.
Okay, so we just got a photo off the camera
Sending you the picture by mail.
from Java code. Okay, that's some nice bright lights. let's try it one more time. And I'll help him not be looking up so high. Come on now.
I'm going to take a photo. 1, 2, 3, smile. Sending you the picture by mail.
Okay, so there we got some of our audience members. We can see you in the front row. So you can do cool stuff with the Java APIs and actually make it more interactive, do more advanced programming stuff. And it's a nice way of showing interactions. I think the main use of the Now, he's not big enough to like lift things or to open doors or do things in the physical world, but it's all great for doing interactions. So one of the things which they've done with the Now robot was to use it with autistic kids who don't respond well to humans like us, but then if you speak through the robot to the kids, it works quite well with them because they can focus on the robot and there's less distraction and they tend to interface with it better than humans. So, in conclusion, we've shown you Java running on Lego Mindstorms, right? Java running on Raspberry Pi. Another Raspberry Pi. Several devices, which you guys have, not me. And a example of a kind of an industrial use of Java, the Duke Pad, or rather the chess robot, and finally the Now robot, where the first group which has seen what the inside of his foot looks like. So with that, I want to thank you guys very much for being here at DevOps France for the tutorial and also being on the live night hacking stream. And for the rest of the time in the session, I'll take a few questions, and then I would encourage you guys to come up and then play and touch with the devices up here in the front. But thank you very much for being a great audience. Okay, so does anyone have a question? Oh, so that's Georgian for coffee. It's just his name. You can name your Now robots. Yeah. Okay. So good question. Yeah. Yeah. The picture code or the. Yeah. Okay. Got it.
Do you the code run on the robot, or you call a server to?
Yeah.
the
So
robot?
this is messaging the robot. It's using their Qi messaging communicating over device. Even when you run the code on the robot, it actually goes through the same messaging, unless you're doing low-level stuff in C. But it just runs on the robot doing local messaging rather than remotely. Currently, they don't have a JVM running on the robots. You can't deploy Java devices to the robot. They only support C and Python, although I've given them the feedback that they might want to add in a JVM in the future.
Okay, so you develop a small framework to send messages to the robots.
Yeah, exactly.
Okay, thank you.
Yeah, good question.
And the class we are seeing here, application session, these are the SDK for talking to
Yeah, so the way it works is there's a C API and this is a wrapper. It's
Okay.
a fairly simple wrapper, so you're just putting in the name of the module you want to access, and then which API method on the C API you want to call. But this is all like subject to change. They're working out the APIs and how it's going to work out for the next version of the Now Robot software. Okay, so it doesn't look like there are any other questions. So this is the chance, like, come on up, check out the hardware. And if you want to see the demos, I'll be happy to turn them back on and you can play around with them. But thank you.